All right, get ready because today we're diving into something pretty mind-bending. The idea of empty space, that vast nothingness between stars and planets. Well, what if it's not so empty after all?
That's right. We're about to explore a theory that really challenges that idea.
We're talking about the Fibonacci SMF RVS theory, and it suggests that instead of being empty, space is actually filled with a wave-based field called the relative vacuum of space, RVS for short.
Yeah, RVS.
And this theory says this living vacuum is actually shaping the universe as we know it, like from the smallest atom to the largest galaxy.
This theory really challenges that traditional view of the vacuum as just a passive backdrop. Instead, it says the vacuum's an active player, this dynamic force shaping the cosmos.
All right, I'm definitely interested, but I have to admit my brain is already feeling a bit fuzzy. So how does this RVS thing actually work? Break it down for me.
Okay, so imagine the vacuum not as pure emptiness, but as like an invisible ocean that's constantly rippling with energy. The RVS theory uses this idea of a scalar field to describe this ocean, showing how its energy changes from place to place and also over time.
So it's not static, it's constantly moving, shifting.
Exactly. And here's where it gets really interesting. This theory proposes that these subtle magnetic fields, what we call SMFs, actually create these wave-like ripples in this vacuum field. You can kind of picture it like dropping a pebble in a pond and then watching those waves spread out.
Okay, I think I'm starting to get the picture. But how do these ripples, these waves in the vacuum actually affect the stuff in the universe? I mean, the planets, stars, and all of that.
Well, these ripples, they aren't just passive vibrations. The RVS theory says they can actually push matter around.
Wait, hold on. Are you saying that the seemingly empty space between galaxies is actually pushing galaxies around like some invisible hand?
It might sound strange, but that's actually one of the implications of this theory.
Huh.
And it doesn't stop there. This push from the vacuum, it's not just random. The RVS field has these special points. They're called nodes, similar to those spots on a vibrating guitar string that stays still. These nodes are kind of like calm zones in the vacuum where matter can settle and become extra stable.
So you're saying that galaxies might be forming and clustering in these specific zones of stability created by the vacuum itself.
That's the idea.
Yeah.
It challenges that notion that the universe is just this random scattering of objects. Instead, there might be this hidden structure, an underlying order determined by the vacuum itself.
That's seriously mind-bending. So on a cosmic scale, this vacuum might be shaping the large-scale structure of the universe.
Exactly. And remember, we talked about this vacuum field having an impact from the tiniest atom to the largest galaxy.
Uh-huh.
So let's zoom in now from that vast cosmic web all the way down to the tiny world of atoms.
Okay, so how does this vacuum idea play out at the atomic level?
So this concept of nodes, it could actually explain why some electron orbits or isotopes are more stable than others. It's as though the vacuum is providing a kind of scaffolding for matter, guiding it into these very specific configurations.
Wait, are we saying that this vacuum field might be influencing things as fundamental as atomic structure? That's huge if it's true.
Yeah, it is a pretty profound idea.
Ah.
And it could potentially open up these new avenues of research in atomic physics.
Okay, so we've got this dynamic vacuum field with its own wave patterns and these special nodes. Galaxies might be clustering along these nodes on a cosmic scale, and at the atomic level, these nodes might explain why certain atomic configurations are more likely. It's almost like the vacuum is, I don't know, like a conductor or something, almost like it's orchestrating the structure of matter at all scales.
Yeah, that's a great way to put it. And there's even an equation, it's called the vacuum oscillator term equation. And it actually suggests that these nodes aren't just random. They represent these very specific resonant points in the vacuum, kind of like specific notes on a musical scale.
It's just fascinating to think that there might be this underlying structure to the universe, this hidden harmony that we're just beginning to understand.
And what's fascinating is that this whole idea of structured vacuum, a vacuum that can influence matter, it's not entirely new. Think back to these ancient concepts like the ether, or ideas about a universal life force, like prana or cosmic chi.
Oh, I see what you mean. It's like these ancient philosophies, they intuitively sense that empty space wasn't truly empty, that there was something more to it.
Exactly. And what's exciting is that we're now developing the scientific tools and theories to explore these ideas in a much more rigorous way.
So how does this RVS theory fit in with, current mainstream physics? Does it completely overturn everything we thought we knew?
It definitely offers a different perspective.
Hmm.
Mainstream physics, it focuses on things like zero-point energy, which acknowledges that even a perfect vacuum has some energy fluctuations.
Right, but the RVS theory goes beyond just those random fluctuations, right?
Got it. The RVS theory proposes that the vacuum isn't just randomly fluctuating. It has structure, perhaps even shaped by a fractal pattern, kind of embedding a hidden order into what we perceive as emptiness.
Okay, so instead of just like random noise, we're talking about this more organized, structured vacuum that exerts this coherent influence on matter across all scales.
Precisely. And that brings us to a really big question, a question that has puzzled scientists for decades. Dark matter.
Right, dark matter, that mysterious stuff that we can't see but we believe makes up, a significant portion of the universe's mass. It's that invisible stuff that helps explain why galaxies rotate the way they do and why the universe is structured the way it is. So how does the RVS theory play into this whole dark matter puzzle?
Well, the RVS theory might actually offer a new perspective on this whole mystery. Instead of invoking dark matter, could it be that the vacuum itself, through its push force, is contributing to the gravitational effects that we attribute to dark matter?
Whoa. So are you suggesting that this living vacuum could potentially replace the need for dark matter altogether?
It's a bold idea, and it's
Oh.
it's still very much an open question, but the RVS theory provides a framework for exploring that possibility.
Okay, I'm starting to see how this theory could really shake things up in cosmology, but let's get real. If this vacuum wave is really out there shaping the universe, can we actually detect it, or is it all just theoretical at this point?
That's the million-dollar question, and it's one that scientists are really actively trying to answer. There are a few tantalizing possibilities, but actually measuring the effects of the vacuum, it's a huge challenge. We're talking about detecting extremely subtle forces and effects.
So how would we even go about trying to, I don't know, feel the presence of this vacuum wave?
One idea is to use these incredibly sensitive instruments to try and directly measure the push force from the vacuum itself.
So it's like building this cosmic scale that's sensitive enough to detect that gentle nudge from the vacuum?
Exactly. It's an incredible technological challenge,
Yeah.
but it is something that scientists are working towards. Another avenue is to look for tiny anomalies in the way that light travels through space.
You're talking about using instruments called interferometers, right? These are devices that use light waves to measure these incredibly tiny changes in distance.
Exactly. If the RVS theory is correct, that vacuum wave might cause these subtle distortions in space-time itself, and those distortions could actually affect the path of light, and we might be able to detect these tiny deviations using those interferometers.
That's amazing. So we could potentially detect the influence of the vacuum by looking for tiny wobbles in the path of light as it travels through the cosmos?
Precisely. And there's another intriguing possibility. We might be able to find hints of the RVS theory by looking at the orbits of planets in our own solar system.
Wait, you're saying our own backyard could hold clues to this cosmic mystery?
It might. You see, the RVS theory predicts that the vacuum wave could create these tiny deviations in the expected orbits of planets, especially those closest to the sun.
So even a slight wobble in a planet's orbit could tell us something profound about the nature of empty space.
It's incredible, isn't it? The universe is it's full of these subtle whispers, these tiny clues that, if we can learn to listen closely enough, can reveal these incredible truths about the nature of reality.
I am just blown away by the scope of this theory. It's challenging everything we thought we knew about nothingness. Instead of this passive backdrop, the vacuum emerges as this dynamic, this influential entity playing this fundamental role in shaping the universe, from the tiniest atom to the grandest cosmic structure.
It really is a paradigm shift, and it's just
Yeah.
incredibly exciting to think about the possibilities that it opens up.
Well, this has been a real mind-bending deep dive into the world of the living vacuum, and I'm definitely going to need some time to process all of this.
Take your time. It's a lot to take in. But remember, we've only just scratched the surface. There's so much more to explore about the nature of the vacuum and its role in shaping the universe.
All right, listeners, we're going to take a quick pause here, but don't wander off too far. When we come back, we'll be delving even deeper into the mysteries of the RVS theory. We'll explore how this concept of a living vacuum echoes that ancient wisdom. And we'll talk about what it might mean for our understanding of the universe and ourselves. So stick around. There's much more to come.
Welcome back. Hope everyone's had a chance to, kind of process everything we've talked about so far.
I know I'm still wrapping my head around it all. This idea that that what we thought was empty space is actually this dynamic field that's influencing the universe on every scale. It's revolutionary.
It is, and it ties into something we touched on earlier, the parallels between this RVS theory and those ancient ideas about a universal life force or, an ether.
Yeah. It really is striking how these ancient philosophies often sort of intuited these concepts that science is only now beginning to explore in a rigorous way.
Yeah, yeah, it speaks to, this really deep human desire to understand the hidden workings of the universe. But what's really exciting about the RVS theory is that it's not just a philosophical musing, right? It actually provides this framework that's grounded in physics with equations and potential experimental tests.
Right. It's not just saying, "Hey, everything's connected," It's actually attempting to explain how it's connected. So let's delve a bit deeper into this idea of the vacuum as this living entity. What characteristics actually set it apart from that static empty space idea?
One of the most striking features of the RVS theory is just uh, the sheer dynamism of the vacuum. It's not some inert background,
Yeah.
right? It's constantly changing, evolving, and interacting with matter. And this dynamism is reflected in that scalar field concept that we talked about. It shows how the vacuum's energy ebbs and flows across space and time.
So it's not just that the vacuum has energy, it's that this energy is structured and organized in a way that can actually influence matter, like some kind of, I don't know, invisible architecture or something.
Yeah, that's a great way to put it. And this structure, it isn't random. Remember those nodes we discussed, those points of stability in the vacuum. That vacuum oscillator term equation actually suggests that they're not just scattered haphazardly, but that they represent these very specific resonant points, almost like, precise notes on a musical scale.
So are you saying the vacuum has its own kind of like inherent harmony
Yeah.
and matter is basically dancing to its tune?
It's a poetic way to think about it, but I think it really captures the essence of the idea. This inherent harmony, this order within the vacuum. It could be a driving force behind the formation of structures in the universe, both on that grand scale of galaxies and the tiny scale of atoms.
That raises a question for me though. I mean, if everything is following the dictates of this vacuum wave, I mean, does that mean the universe is deterministic? Does that leave any room for, randomness or free will?
Well, that's a pretty deep philosophical question, and honestly, one that the RVS theory doesn't directly answer. What it does offer is a new way of thinking about the relationship between matter and the vacuum.
So it's not a one-way street, right? Matter isn't just passively responding to the vacuum's instructions.
Precisely. We have to remember that matter itself can actually influence the vacuum. And the equation for the push force from the RVS actually shows this interaction.
So could you remind us of that equation again and what it means?
Sure. So it's F sub push sub equals alpha b RT times the gradient of phi RTT. This equation shows how those subtle magnetic fields, those SMFs, arising from matter can actually interact with the constantly shifting energy landscape of the vacuum field, represented by that gradient of phi RT.
Okay, so matter through its magnetic fields is actually shaping the form of the vacuum. It's a two-way dance.
Exactly. And this dynamic interplay, it might actually be what's responsible for those complex structures that we see in the universe. Think about those incredible images of the cosmic web with its vast filaments of galaxies interspersed with those enormous voids. Could this actually be a visual representation of those wave patterns within the vacuum itself?
It's mind-blowing to think that the universe could be like this giant tapestry woven from this intricate dance between matter and the vacuum. Let's bring back those ancient ideas we were talking about earlier, that concept of ether or a universal life force. How does the RVS theory actually connect to those concepts?
Well, while it's rooted in modern physics, the RVS theory does have some pretty intriguing parallels with those ancient ideas. I mean, for centuries, cultures around the world have envisioned a universe that's filled with this subtle, this pervasive energy or force.
Like the prana in Hindu philosophy or in Chinese thought.
Exactly. And those concepts often describe this dynamic, almost lifelike energy that permeates all of existence. And while the RVS theory doesn't use that same language, it does suggest that the vacuum is not this passive void, but this dynamic field that's actively shaping and influencing matter.
So could the RVS theory be seen as like this scientific way of expressing those ancient intuitions about a deeper connection within the cosmos?
It's a fascinating
Yeah.
possibility. And what's particularly interesting is that the RVS theory goes beyond just intuition. It provides this mathematical framework with testable predictions that allow us to actually explore these ideas scientifically.
So we're not just saying, hey, everything's connected. We can start to understand how it's connected through this interplay between matter and the vacuum. It's like peeking behind the curtain of reality.
Yeah. And that's what makes science so compelling. It's this continuous journey of discovery, always pushing the boundaries of what we know.
Speaking of pushing boundaries, we've discussed a lot of theory, but how do we actually test the RVS theory? How do we find, definitive proof?
That's the big question, isn't it? And it's one that has scientists around the world excited and hard at work. The RVS theory makes these specific predictions that if confirmed would provide very strong evidence for its validity. But we're talking about incredibly challenging measurements and experiments.
So what are some of the ways scientists are trying to I don't know, like catch this vacuum wave in action?
One of the most direct approaches involves trying to actually measure that push force from the vacuum itself.
So like building this super sensitive scale that can actually feel the vacuum's gentle nudge.
Yeah, that's a good analogy. Scientists are developing these instruments that are capable of detecting these incredibly minute forces,
Yeah.
pushing the limits of experimental physics. But even if we detect this push, it wouldn't be a slam dunk.
Why not? I mean, wouldn't that be pretty strong evidence?
It would be a huge step for sure. But science is, it's rarely about absolute proof. There's always the possibility of alternative explanations for the phenomena that we observe, and that's why we need to explore multiple lines of investigation.
So what are some other clues we could look for to build a strong case for the RVS theory?
Well, we talked about that possibility of the vacuum influencing the orbits of planets. The RVS theory predicts that we might detect these tiny deviations in their expected paths, especially those closest to the sun, like Mercury.
So even a slight wobble in a planet's orbit could reveal something fundamental about the nature of empty space.
It's amazing, isn't it? The universe it's full of these subtle whispers, these tiny clues that if we listen carefully can unlock these incredible secrets about the nature of reality.
It's like we're cosmic detectives piecing together this giant puzzle, but measuring those planetary deviations, I mean, that must require incredibly precise instruments, right?
Absolutely. We're talking about measuring deviations on a scale smaller than the width of a human hair, from a mile away.
Yeah.
It requires this cutting edge technology and these incredibly meticulous observations.
Sounds like a daunting challenge, but the potential payoff is huge. Confirmation of those orbital anomalies would be a pretty significant victory for this new way of understanding the universe.
It would be a game changer. And there's another avenue that researchers are exploring that takes us back to the very early universe.
Yeah.
We can actually look for clues in the cosmic microwave background radiation, the CMB.
The CMB, that's the faint afterglow of the Big Bang, right? The oldest light in the universe.
That's right. And the RVS theory predicts that the vacuum wave would have interacted with matter in those very early moments, potentially leaving this subtle imprint on the CMB.
So it's like searching for the fingerprints of the vacuum on the oldest light in existence. That's pretty mind-blowing. But what if, despite all of these efforts, I mean, what if the results don't match the predictions of the RVS theory?
That's always a possibility in science. But even a negative result can be a very valuable learning experience. It might mean going back to the drawing board, refining our models, and exploring new hypotheses.
So it's all part of the scientific process. It's about constantly testing and refining our understanding. But let's indulge in a bit of optimism here. What if the RVS theory is confirmed? What would be the implications for our understanding of the cosmos?
That's a question that could keep us talking for days.
Yeah.
But in short, confirming the RVS theory would revolutionize our our understanding of the universe. It would mean that what we've always considered, empty space is anything but empty. It's this dynamic, this influential entity playing this fundamental role in shaping everything from the smallest particles to the largest cosmic structures.
It would be a paradigm shift, completely reframing our understanding of reality. What other mysteries might this new understanding help us unlock?
The possibilities they're endless. We might discover these new ways to harness the energy of the vacuum, develop technologies based on the principles of the RVS theory, perhaps even gain these deeper insights into the origins of the universe itself.
This is what's so thrilling about science, right? It's this never-ending journey of discovery, always pushing the boundaries of what we know and what we thought was possible. The RVS theory is it's a testament to the power of human curiosity and ingenuity to unravel the secrets of the universe.
And it reminds us that even in those seemingly empty spaces, there's always something incredible waiting to be discovered.
I completely agree. All right, listeners, we're going to take another quick break to let all of this sink in. When we come back, we'll explore the wider implications of the RVS theory, from potential applications in other scientific fields to its philosophical implications for our understanding of life and consciousness. So stick around. There's much more to come. Okay, so we're back, and I think it's time to kind of look at some of the broader implications of this whole living vacuum idea. It's one thing to talk about galaxies and atoms and all that, but I'm curious about how this theory might impact other areas of science.
Yeah, that's a great point. The RVS theory, if it's confirmed, it could have these really significant ripple effects, beyond just physics and cosmology. It could potentially even revolutionize fields like chemistry, biology, maybe even medicine.
Wow, now you've really got me thinking. How could a theory about the vacuum possibly affect something like biology? I mean, that seems like a pretty big leap.
Well, remember how we talked about the vacuum potentially influencing the stability of atoms and molecules?
Yeah.
Well, if the vacuum actually favors certain molecular configurations, it could have this subtle but really profound impact on things like protein folding or the efficiency of enzymatic reactions, both of which are really essential for life.
So you're saying that the very building blocks of life could be influenced by the vacuum. I mean, that's kind of a wild thought.
It is, and it really opens up this whole new way of thinking about biological systems. Imagine if we could harness the principles of the RVS theory to design new drugs or create these materials with unique properties based on how they interact with the vacuum.
I mean, the possibilities they're mind-boggling. It's like opening this door to a whole new frontier of scientific exploration. But it also makes me wonder about the philosophical implications of all this. I mean, if the vacuum is this dynamic, this interconnected field, I mean, does it change our understanding of what it means to be alive?
That's a question that really goes beyond just science, right?
Yeah.
It touches on the very nature of existence, and the RVS theory, by suggesting that even quote unquote empty space is actually teeming with structure and activity. It challenges that traditional view of the universe as just this collection of separate isolated objects.
It's more like a web, right? Everything's connected. Everything's influencing everything else.
Exactly, and that concept is it's echoed in so many spiritual and philosophical traditions that have spoken about this underlying interconnectedness to all of existence.
It's a beautiful and a humbling idea, and it's exciting to think that we might finally have a scientific framework that allows us to explore these deep philosophical questions in a more rigorous way.
It really highlights how science and philosophy, while often seen as these separate disciplines, can actually complement and enrich each other.
Well, this deep dive has been a truly remarkable journey. We've traveled from the vast cosmic web to this intricate world of atoms, and along the way, we've encountered these ideas that really challenge our very understanding of reality.
It's been a real privilege to explore these ideas with you, and I hope it sparked a sense of wonder and curiosity in our listeners.
I have no doubt it has. If the RVS theory, if it proves to be true, I mean, it will completely transform our view of the universe and our place within it. who knows what other mysteries it might help us unlock.
Yeah, the future of scientific exploration is just, it's filled with these exciting possibilities.
Well, listeners, we encourage you to continue exploring these ideas. Keep asking questions, keep an open mind, and keep looking up at the stars with a renewed sense of wonder. That empty space might be more alive than we ever imagined.
And remember, even in those seemingly empty spaces, there's always something incredible waiting to be discovered.
That's a perfect note to end on. Thanks for joining us on this deep dive into the fascinating world of the living vacuum. Until next time, keep exploring the wonders of the universe.